That's all of us. We'll now watch and see. Yep, I'm here in audio. Hooray! Looks like we're live. Somebody on the Twitch stream, let us know if you have any problems. Can someone else speak, please?
Can you hear us?
Hooray!
Can you hear me?
Testing.
I hear some echo from somebody, though. All right. Cool. Greetings. Yep, audio, everything good. Cool. Hooray! It's the ASP.NET Community Stand-Up, June 16. Hello, Damien. And today we're joined by Sébasten and David Fowler.
Hey.
Welcome back, folks. And so you're going to be showing us some performance infrastructure stuff. Hello, Damien.
Yeah, right, Seb?
Today we're joined.
Yes, tap.
Exciting. Okay, cool. Let me jump right into the community links, and then we will wowed by
Someone is feeding the YouTube audio back in through their microphone.
Yeah. Don't do that.
Not me. I don't have YouTube open.
Or Twitch.
Or Twitch.
All right. Things happen. Everyone can hear, continues to hear. Great, wonderful. Cool. Here we go with the community links for this week. So these are, I will publish these in the chat and everything. It's ASP.NET Stand-Up 2020-06-16. So here's, don't worry, I'll be sharing these all out at the end. Here's what I got for you today. First of all, Jeremy Lickness with a huge 3-part series, building a line of business app using Blazor, WebAssembly, and a lot of entity framework goodness. So there's a ton of good stuff in here. I love this because he's building out, some real world concerns. So some things I want to point out here. One is he's got auditing of user account information. So he goes through and he shows how he sets that up using entity framework. So he's setting up some things with change tracking. And then the end result of that is you actually see as users are edited or changed, he's tracking that. So that's a common line of business scenario that you'll see. And so that's cool to see how he's got that set up. He's got some other things with data annotations, etc. Want to point out some other things in the other parts of the series. So part 2, he shows off some cool stuff here. One thing, let me see, he's using some stuff using versioning, and he's also got a repository pattern here to allow for testing. And in the third one, and I'm just showing the highlights here, these are definitely a couple of cups of coffee. One neat thing here he's showing is filtering with debounce. And so in this one, there's a search interface. And the problem that you run into with searching, where you allow typing and you're filtering as you type, is that it's constantly running the search every time you type a character. So he's doing the standard debounce here, where he's got a timer running and only comparing. And he's saying if between when the timer started and ended, if what I've typed has changed, then run another filter. So that's kind of standard. Well, I think this actually shows a lot of the power of Blazor programming model, because I wouldn't want to write debounce code in JavaScript. I'm not.
Actually, it's probably easier in JavaScript.
Yeah, maybe. I would be a little worried. Here I can keep in my standard .NET timer world, so anyhow, that's kind of cool. And he's got a bunch of other stuff here, queries across the wire. He's doing some things where he's sharing UI components. Lot of cool stuff. So. Wonderful stuff. And reminder, we've got a EF community stand-up as well going on. So they're showing off a lot of cool stuff in those. Another neat Blazor thing, this is Blazor REPL. So this is an example here. One is where you can type in your own stuff and do the REPL thing. They've also got some built-in ones. So some things like a counter demo. They even have here is a form demo. And so this is all the code. And then if I hit run, it actually processes and runs it interactively. So this one is a little bit more complex, but this is a full REPL thing showing this all. So pretty neat stuff. One or two more Blazor things here. This is a neat deep dive by Ed into the render tree. So explaining how the render tree is constructed, and showing the abstraction between the DOM and the render tree itself, and explaining. So he goes through and explains how it's constructed. Some nice visuals here, showing how it's all fit together. And then he kind of, towards the end of this, talks about, and he shows here how you can construct things and work directly with the render tree through the component base. One thing I have to get upset, though, is here he's got multiple H1 elements. He iterates through at one point and creates multiple H1 elements, and I don't like that at all. But here he shows building out a render tree. And then finally, at the very end, he talks about a place where you can, if you're directly editing things in the DOM, you can get a conflict. And so he shows using the key, or you can set the key to allow for direct tracking of an element. So really good stuff there. All right, here's one more lengthy Blazor post. Tons of good stuff here in Blazor lately. So Daniel writing about using Blazor, TensorFlow, and ML.NET to identify images, in this case, broccoli. So he goes through, he shows how he creates a TensorFlow model and trains it with a bunch of images and labels showing what those images are. So this is actually just a console application that he runs separately. Creates a TensorFlow model, shows this neat visualizer, which is pretty cool. And then he dumps that into a Blazor application with ML.NET. And then goes through and shows some additional things you've got to do. For instance, setting it up with system drawing on Mac or Linux. And then there's some more kind of in-depth stuff as far as actually kind of cleaning it up. He does some nice things, even as far as like when you upload the image, he does some nice things where he actually loads in the image and shows a loading indication. So for instance, here he's loading the image by decoding the binary base 64 binary here and showing that. So pretty cool stuff. It's neat. I like that ML.NET works with existing things like TensorFlow, and this is cool to see a kind of fully integrated solution there. Cool. All right. Update from Elon on mobile Blazor bindings. Not a ton of stuff in this one. Some things like the update for Xamarin Forms 4.5, simplified, more web-like syntax. So instead of this button text equals, you can have button and have it between. And also some things including like CSS improvements. I like also that he always calls out community input. So so that's pretty cool too. All right, coming up very soon, this Blazor Day. This is on the 18th, and there's a ton of stuff. There's a lot of great sessions. So, of course, Dan Roth, we've got Ed, we've got, just all the usual suspects of Blazor world. So it's great to see this event coming up. All right, moving on from the Blazor section. Here we have a nice one from Andrew Locke, and he's talking about host filtering with Kestrel. So he points out the problem that you can, if you're not specifying host names, you open yourself up for some vulnerabilities. So he shows some examples with things like DNS rebinding, cache poisoning, and password reset hijacking. So some things with DNS rebinding. This was something I like, for instance, here. This is an example where we have another host name. This is a subdomain, and the subdomain is set with a really short TDL and like 60 seconds. And then it's updated to point to another URL, and then they start doing XHR requests. So scary things. So what he shows here actually is a very simple solution, which is actually setting your allowed hosts. So by default, it's just star, but you can set them directly. So, and then he shows here by setting that directly, he's allowing site-A, but not site-B. So here we get an invalid host name. So, stuff. One other kind of security-related thing I thought was interesting recently. So Manjula is writing about target_blank, and she points out that by default you can set, like if I have a pop-up, and that pop-up can maliciously set window.opener.location, and it can redirect to something that looks like. So for instance, if a site has a window.opener, that window.opener could then impersonate like a Facebook login page or something, and all of a sudden I'm entering my credentials, giving my credentials away. So she points out that there is the no opener rel attribute that I wasn't aware of. So there's no opener, and then also for IE11, you're safe for also putting in no referrer. And what that does is your _blank does not allow changing the window.opener. So neat stuff. All right, let us encrypt from Nate McMaster. So a few things to be aware of here. One is it's let us encrypt, or instead of let's encrypt.
I believe it's pronounced Latus.
Latus encrypt? That makes sense. So yeah, so that is an update. It also does the automatic update for automatic request for your certificate at 30 days, which is really nice. So this is some things to be aware of there. All right, some cool announcements. This was just from today. gRPC Web now available. So we previously, I think, both showed this off on the show and also showed the previous longer blog post explaining it. So, oh, okay. Okay, so this is, so gRPC Web offers support for like apps from the browser, support from IIS and Azure App Service, which is nice. Yeah, so what's cool, Damien, is I cannot turn on, you'll see here, I've got this actually set focus.
I'm sorry, now I know I can do that. I'm just going to spam you.
I know, Teams does not respect those settings, which is kind of annoying. So, yeah.
We should make sure you send feedback.
Yep, that's true. So yeah, so anyhow, this is released today, so this is very cool. So gRPC Web now available. Congratulations, team. Hello, everyone. Hey, Glenn. What's up? Also, Tim with the Web Live Preview. So Web Live Preview, this is an extension for Visual Studio for Windows. You can, oh my gosh. I'm going to end the community section very early. So with this, you can now go in, you can, you can both interact directly.
Stay on target.
Right. You can interact directly, but what's also cool about this is that it allows interaction with the browser tools. So you can actually go in with browser tools, update things, and it'll update directly back into your code in Visual Studio itself. So very, very exciting stuff. Give it a try and give them the feedbacks. Okay, last thing, very quick one here. Saurabh with the ASP.NET Core for .NET 5 Preview 5 updates. Not a huge amount in here, very easy to update, and the only update here is reloadable update via configuration for Kestrel. So, but if you're on the .NET 5 train, you should update for the latest previews. And I am going to share this link out, and I am done sharing my screen. So I will go back to this screen, and now we're all back. Awesome.
Wait, John, you said we don't have any features in ASP.NET Core Preview 5?
I said the only one that was in Saurabh's post.
But is your claim that we don't have features and that we don't do any work? Is that what you're saying?
Well, I implied it.
Got it.
Yeah. I mean, you called yourself out. I just left the opening. All right. So what do you folks have to show us today?
What do you have, Seb?
I have, well, I could show Orchard Core RC2, which we shipped this week.
What?
But,
Vetoed.
but I won't. So now, yeah, so the idea is that we've worked for too long now on performance, and we've improved the system we are using to benchmark ASP.NET and everything else to a point that we think it's reusable by everyone who cares about perf. So we wanted to make it more usable, more open sourcey, with documentation and just clean stuff. So we made a new repository to get it open source and to let everyone use it if they want to make benchmarks on web apps, whatever web apps, including .NET. It's better on .NET actually. So yeah, the idea is today to show you how it works, how we measure stuff, and how you can reuse it to measure your own apps, or just help the .NET team make things faster for everyone. So
the background story is Seb made some infrastructure that is open source today in benchmarks, and it was basically over time it kind of grew organically into this thing that we use to test Tech Empower on all of our scenarios, and we track it via the Power BI that Damien shows like every now and then on stand-ups or in other places, and it's how we track our Tech Empower progress, so we can run this thing on all of our perf machines to show perf numbers. And as the team grew, as more people got involved, it became really hard for Seb to run all the perf tests. So he tried to make it easy for everyone to run. And that kind of grew and grew more organically. And the command line kind of grew into this monster of a bunch of things to pass in. So Seb did kind of a reboot to make it easier to basically run these performance tests. And I saw it and I said, Seb, we have to make this thing we have to make this thing a product because it actually is super useful by itself. And we had a bunch of internal teams and other people in general want to test their stuff, and we'd always go and tell them, we have this thing, it doesn't have any dots, but if you can figure it out, then that makes sense. So we made a repo like how long ago? Like maybe 2 weeks ago, and I forced Seb to name it, and we had a name. We named it. We did some stuff. And now we think we have what we think is a super cool product for perf testing, and maybe load testing too, and stress testing. My video frozen still? Can you guys see me move?
No, fine. Nice, good. Nice, good.
Okay, it's your internet. Mine's fine. So yeah, so Seb, show what you have.
Yeah, we should.
First of all, what's the name? What's the name?
Well, that's Damien's forced us to use it, so I mean, you can tell it.
I have no power. I simply made a suggestion and I indicated a preference. And lo and behold, it's the one that y'all ended up using. You can't blame me.
That's because we got just annoyed trying to pick names. Naming is really hard. So
Just
we have
using
four
Word.
names.
We didn't even say that. It's called Crank. I'm sharing my screen now. I hope you can see it. We didn't even try.
Yeah.
Okay, thank you. And so I just asked my wife to make no sound, no noise, but she said my daughter has a piano lesson in 30 minutes. So I'm very sorry. We'll see how it goes. Yeah, so that's the repository. It's still private. It will be public soon. I keep hitting F5 and it's not public. It's because of David. So we'll see how it goes. So this is the repository .NET/Crank. Previously it was, it's still there. It's ASP.NET benchmarks. This is where we have everything, the infrastructure, but also all the apps we want to measure, and lots of things, and too many things. That's why also we made a new repository to just separate what we do in the ASP.NET team and what everyone should be able to use, which is just the infra, all the tools that we use. And there is also better documentation. And we have a CI. Now it has tests and it builds stuff. It's no more like a junk
you mean before, because you could break it easily because it had no tests. Oh, good. So we have tests now. Good job, Seb.
Nice.
Yeah. So the idea of this tool is to be able to deploy jobs, apps on different servers and let them run like a web app, a load generator, a database, Redis, whatever you want on whatever machine you want. And then it will gather some metrics that will be returned to your machine to be stored somewhere in a database or in JSON, so you can see the result of the benchmarks.
Right. So it orchestrates jobs, right, on machines, and then the controller will coordinate multiple jobs across multiple machines, gather metrics, gather stats about all the jobs, and bring them to some, and you can store them in some form of storage, database or a file.
So on this schema, what we see is that the controller is like CLI that will talk to agents. Every agent is installed on a machine or just on a single machine. It depends on what you want to do. And every agent can run Docker jobs, .NET projects, or just executable files. Because if you don't want to build a .NET job, you might have something that is already compiled, you can send it directly. Or if you want to run a Docker job, you can also do that. So this gives us a lot of flexibility about what we want to run and to benchmark. And an agent is just a .NET service that you install on a machine that will be part of the benchmarking. So it's a .NET web app. It talks HTTP to the controller, and it will just start your jobs and stop them. It's the orchestrator, and we call it the agent. And the controller is a command line tool that we call crank. This is a crank agent. This is crank. And from there, we can start commands that will orchestrate all the agents that will start the jobs. And the agent is able to measure what's happening on each application, like the CPU usage, the memory usage, network swapping memory, and things like this. And then each app can also return custom metrics. And that's a very powerful feature, because then you can decide on what information you want your app to provide to the agent, and that will be forwarded to the controller. So the controller will have a view about everything that's run on the different machines.
Yep. Also, the agent can do things like collect profiles. So you can imagine running a load test and then capturing an allocation profile or capturing a CPU profile or per view trace. And it can basically run remotely, collect information, and send that data back to the controller as well. So you can kind of get metrics, logs, traces, a bunch of different things from the application.
Yeah, so when David mentioned that it grew organically, it became a monster, because at first we just wanted like to run an application and start WRK to measure RPS, okay, requests per second. That's all we wanted to do. And then we were like, okay, but we need to measure memory, to measure latencies, to measure network usage, to measure is the GC enabled or not? Is the server GC enabled? Or what version are we actually running? Is it like 2.1 or 2.2, or is it whatever? And then we kept adding arguments to the command line, and more arguments, and more features. Like in the end, we have, I don't know, maybe 50 different things that we can measure with these two.
And then Seb would go on vacation, and we'd have to find the wiki page.
The OneNote. The OneNote
that had all of the magical incantations.
The best part was the first version. Like, we had a single benchmark application that had all the scenarios, and every single scenario was a flag you pass on the command line. So you'd like run Kestrel with plain text with this thing, all these arguments, and
I remember that one.
It was crazy. It was like, wow.
It was born. The history of this thing is literally, I think I started building that app, and it just had some rudimentary arg passing in the web app itself. And you would say, do you want to run the database tests, or do you want to run like the middleware tests? And I used some ridiculous, like, naive pattern matching to try and turn middleware and stuff on and off. And then Mike, I think, built the driver that would let us send jobs to it remotely when he was working on our performance stuff as well. So then we had like infrastructure. That was our first piece of like always running infrastructure that we could submit jobs to via SSH or whatever. And then, of course, we wanted to get into automation. So then you want things like the build would automatically push a job to the infrastructure and then give you results back. But then we still want to be able to do ad hoc so that a dev can make a code change, build the assembly locally without having to push it anywhere, but invoke a job with their private assembly. So that was something that I know a lot of people did, or this private copy of .NET Core, for example. So I know we did that for a long time. And then we, as Seb said before, we had to start onboarding other teams because it wasn't just ASP.NET anymore. there'd be someone from the .NET Core runtime team would be working on a fix to improve the performance of one of our scenarios, and they would need to be able to use this tool as well. And so like you'd throw them the OneNote and they're like, what? Like, what do I do here? And so this has really grown into something. And then we wanted to start running competitive stuff too, right? So not only do we run our own .NET server, but like Tech and Power, we want to be able to track our performance on our hardware versus other frameworks or other things that are implemented different ways, so that we can get like for like numbers on the same machine. So it needs to be able to, it needs to be able to run anything. So all that has led to where we are right now, which is pretty cool.
Yeah, and Seb, I think one day we were in a meeting, and Seb had an epiphany that he could rewrite the thing to be super generic. And I think he spent like, I don't know, 2 weeks just scrapping the old, not scrapping it, making a brand new agent that we're seeing here. That was a new and improved system. And over the last couple of months, it kind of just got better and better.
It's interesting. Brian Hauer from Tech and Power said conceptually it sounds similar to the TFB toolkit itself.
Yeah.
So.
Yep.
Yeah, so here I'm also showing what is the goal of our infrastructure to be able to measure perf on different scenarios and chart it and filter it and compare scenarios. So as Damien mentioned, we measure, for instance, where can I find some? Where are they? Oh, the filtering is too much filtering maybe. Yes, here. So we measure different frameworks like Node.js, Rust, Actix, Go. So for instance, you see on the JSON scenario, Actix, FastHTTP, which is Go, on Mono, Netty, Node.js, ulib, C++, and we can then check the boxes and then see the comparison on the charts or the internet.
And it's the counters. So if you scroll down for like .NET scenarios, you can see all the counters for all the stats, like RPS, memory, thread pool queue usage, Gen 1, Gen 2s.
And importantly, that's a combination of both .NET runtime counters or event counters or metrics and platform counters, so that we can gather information directly from the machine that's running it, like the underlying OS, or we can get it from the process itself, or you can deploy another job that's job is to gather metrics from the other job that's running. Like you can do all that type of composition. And then ultimately it all just gets put back into a database, and then you can visualize it whatever you like. We're using Power BI, but the idea would be if you want to deploy this yourself, the data goes to wherever you want the data to go to, and then you could visualize it using whatever tool you want to.
Right.
Are you able to correlate things together? For instance, let's say there's a GC is causing a slowdown in perf or whatever, like, and see, okay, that was caused by this specific.
Yeah, so just by virtue of all these time series being synchronized, right? So these graphs here are all showing the results for whatever is currently selected. And so if you see like a jump, let's have a look on the top left-hand graph where it says RPS. You can see we have a step up back in May. So we got faster, right? And that happened on May the 9th, May the 8th. And you can see all the metadata in the tooltip, which is a feature of Power BI. You can pick other fields to show up in the tooltips for each of these data series. So we can see what build of ASP.NET Core it was, what build of .NET Core it was, what session ID, what job it was. And so we can look at that, and then you can hover over another graph, like how much memory was being used, or what was the latency, or what was the CPU, or what was the contention rate, and you can find the same dot, right? The same series dot at the same point in time with the same runtime version, and you know the correlate. So you can see right here at around the same time, a fix obviously went in that made a change to the thread pool, because before that series of time, the thread pool items was much higher. And then it went down, and that seems to have happened around the same time that the RPS went up.
Right. And this is used when we also track regressions. So if we do have the perf regressing in some form, memory getting higher, or CPU getting slower, or RPS getting lower, we can like take two commits and diff them and figure out what change. Well, hopefully figure out what changes in ASP.NET Core or .NET Core caused that issue. And Seb has a bot that actually scans through commits that we call the regression bot, and it files issues when the level of variance for regression has hit some threshold. So here's an example of one, a 4% change, right?
And then
it tells you like.
What about this? Should be hooked up to get blame and automatically like.
Well, it is.
penalize.
There's a link down the bottom.
Well,
Look.
no. So you'd only have that if you were super confident that it was like this was a problem.
But at
Most
least
of the time,
it can give you a diff.
Yeah. It takes some depth to go figure out, okay, this change maybe caused the regression. For the most part, it's pretty clear, but sometimes it's not obvious, and it could be a red herring.
And we also obviously have environmental changes from time to time, whether it's kernel patches or your drivers and things like that. Now, like any good performance environment, you want to try and really coordinate those and make sure you do those in a very deliberate fashion. But sometimes things come through and we don't realize that it was an environmental change that caused it. But we've gotten a lot better at that. I think it's fair to say, I think, Seb, haven't we? We haven't really had one of those.
Well, there is one.
There's one right there.
Well, but I can explain it. That's fine. That's a good environmental change. But you can see it here because I'm measuring HA proxy and an HTTP client proxy. So this is a page where we track proxy performance. And if I compare HA proxy to HTTP client, you see the two of them, they have an issue. And it's not because of the net runtime change that HA proxy went slower. It's actually, it's a different discussion, but this is how we find that it's an environmental change and not like just. So
that's another good reason to be running competitor or non.NET benchmarks always as well, because as I said, it makes it very clear when an environmental change potentially impacted everything.
And you see here, for instance, everything didn't work. So yeah, there was something going on. Machine was down or CI wasn't running, whatever. Yeah.
So we're running this on all of our environments now, right? So we have, Windows, we have physical Windows, we have Linux, physical Linux, we have a cloud-based Windows and Linux as well. And then we have a couple of other environments that we do ad hoc, right? With the from other teams, they have hardware that we sometimes are able to utilize to get some variance. Oh, we have an AMD machine as well. So we have a Linux AMD server. So we've started doing comparisons of the Epic Rome, the new AMD server architecture, and to have a look at how we do on that sort of hardware as well. And we run all of these on, and you can see we've got ARM in there as well. So we've got a whole bunch of different physical machines and virtual machines under cloud that we're running all of these benchmarks on all the time so that we can compare these things. So
there's a question from Wraith about Tech Empower benchmark running against SQL Server. Do we have any that explicitly?
No comment. I've got nothing to add to that today, unfortunately. I'll chase up the appropriate contacts again, but there's a long-standing issue on trying to get that enabled.
Okay. Because I was thinking too, especially now that there's the SQL Server for Linux, it'd be interesting to compare with that too. Cool. Good stuff.
So I wanted to show you some demos. So this is the end result, but how do we get to these numbers? How do you run a benchmark like this? So I was showing different dashboards because every team in .NET might have different requirements. Like the tiered compilation team wanted to analyze the differences between a tiered compilation on and off. How is it good for RPS or latencies and startup? gRPC, like James, has lots of benchmarks for comparing Go, native, and .NET implementation on the server and on the client. So we can combine everything here with different type of payloads on Linux and on Windows, and he gets all the charts he wants to track the perf and of these things.
And to be clear, this is .NET and non.NET code running in the benchmark.
Yeah. So, and I will show you how to run that with the same command line. And you see here.
Show us, Seb.
Yes, boss. I wanted to close that.
I didn't see it. Hide the screen.
What? So here I'm on the clone of the Crank repository, but you don't need that. I will use it because I have samples there that I want to reuse. So Crank is available as a .NET tool. Actually has two .NET tools for the controller and for the agent. So if I go on the getting started.
By the way, those docs were built, the diagrams were built with draw.io. And that's my contribution, is to draw super fancy diagrams to be an architect.
Very nice. You are an architect now.
I'm going to get
Job
you a
done.
big A architects t-shirt.
Job over.
So here, .NET will install the crank controller and the crank agent, and then you're able to run crank for the controller and crank-agent to run the agent. So if I just want to run an agent locally because I want to do some test on my local machine that will run all the application, I can do crank-agent, and it starts the .NET service. It's a .NET app that will accept any jobs from the controller. And here it's on the local host on 5010 port. And now the agent is ready. It's waiting for jobs to run.
Question, so if you hit that endpoint, what happens?
Nothing fancy.
This is the best part of the whole demo, just so you guys know. That means it's working. That means it's working, okay? It's up and running.
And later you will see,
you need to bootstrap this site out.
I could use NSwag and have all my APIs listed and have a nice UI.
It should be Swagger, right? Yeah, maybe it should be Swagger.
Yeah, at some point. It's open source. You can provide a PR on David.
It will be open source.
So here, and now what I want to do is run, I will run a web app, an ASP.NET web app that is on the samples repository. So if I look at that, I have it there. If I open my hello folder in the samples, the hello folder is just a simple middleware standard app that uses endpoint and returns hello world. Okay, it's just returning hello world on the root path. Okay, and it's also displaying some .NET version that it's running on, but we'll see later. So that's all it does. So program CS, startup CS, CS Proj. The CS Proj says it can run on 3.1 and 5.0, okay, multi-targeting. And that's
Core 5 or Net 5?
Yeah, you could change that to the nice short TFM now if you wanted to. Net 5.
You want to break your demo? I don't know, man.
I will do it just for you, and you will see it will work.
Yeah, there we go. Delete that.
Because it broke me when we did a change, remember? 2 months ago. So here, the idea is that from the command line, crank, I need to be able to describe the benchmark itself. The benchmark I want to run is made of this application, the web application that I want to deploy somewhere, and a load generation tool that we'll use to simulate some HTTP client, well, some HTTP traffic on the web app and measure the result. This tool will use WRK or Bombardier. I think here I'm using Bombardier. So this file is describing everything that we need to do to run a benchmark. I won't use this one actually, excuse me. I will use the local one here, which is simpler, you will see why. So here, this file defines jobs, scenarios, and profiles. So if I focus on the jobs first, it says, I have a job named server, and the source is in this local folder. Okay. And the project I want to run is the CS Proj here. And the ready state text is application started. So what it says is, the application is local in this folder. You need to build a CS Proj file. Remember, we can run Docker files, CS Proj, and executables. And to detect that the application is ready to accept requests, you have to check that the text application started is available. And this is what .NET apps, ASP.NET apps usually output on the console to say that they're ready. So that's all I need to do. And then here I'm importing another job, which is the Bombardier job. And this job has the same definition as that, but explains how to run Bombardier, which is a console app made in Go to generate some HTTP load. It's like WRK, but in this example, Bombardier is very interesting for us because it can run on Windows and Linux. WRK we only run on Linux. So that's why I'm using Bombardier for these demos. The scenarios is using existing jobs by explaining what to run and when to run it. So here it says the scenario named hello will deploy something called an application that will be based on the job server. So the web app I just defined here. And then it says, I have a load service to deploy, which will be based on the job Bombardier, which is defined in this file. And the variables for this job are that the server port is 5,000 and the path to request is /. Okay, so that's like a Docker Compose file that will explain what are the components of my system and what to deploy. So this one and then this one. And then the profile will tell the tool where to deploy every job of my scenario. So it will actually define that for the jobs, the application endpoint will be this machine, my local machine, and the load one will be this machine. So the endpoint is the URL of the agent that will accept the job, that will get the job from the controller. And in my case, I just started an agent on my machine on 5010. Okay. Here, the two jobs, I will send them to the same local agent. So you usually don't do that when you want to do a benchmark, but for the sake of the demonstration, I will just use my own local machine to run everything. And the server URI is a variable that is used by Bombardier. If I open the file, I will open it quickly just to show you that it's the same thing that has a job. It has variables that will help me define the command line to run this Bombardier. And the server URI is actually the one that is used to target the application to send HTTP requests to. So if I go back there, the server URI is also localhost. Okay, and the port will be 5,000, which is the default one on this ASP.NET app. So now from here, what I can say is crank, and then I will pass the configuration file, which is in samples local this file. And from there, I can say which scenario I want to run, because there might be many. In that case, it's just hello. And I will select a profile, and there is only one, which is local. What's happening now is it's sending the first job, job one, to my local machine. So here, using local folder, so it's using the local folder, it's uploading the local folder to the machine. And if I look on the agent got the source code and now accepted the job and is currently seeing that it wants to run in Netcore app 3.1. So it's downloading all the requirements for this app, which is the runtime 3.1.5, the new SDK, well, the latest runtime, the latest SDK, the latest ASP.NET, and the latest desktop runtime. So here, downloading everything and installing everything. So it might take some seconds to run. And how it found this version, it's because if you look at the CS proj, it was accepting two TFMs, Netcore app 3.1 and Netcore app 5.0. So by default, it says, okay, there are two of them, I take the first one. This is how it works. And then which version? So is it the one that is currently built on the nightly feed of ASP.NET or just maybe an old one? No, it's taking the latest available, publicly available, which we call current. And currently,
do you get that from where do you get those different values then to map the SDK to the current?
So I could write a PhD about that, but there are feeds and metadata files online on the GitHub repositories and NuGet and private feeds that will contain this version. So in this case, it found it was 3.1.5, and I will show you how it can detect more versions. So it found everything, it stole everything, and now it's running. You see the application is running, and it's starting doing the same thing for Bombardier. So Bombardier is also configured to use 3.1.5, actually, Netcore app 3.1. The app that we are building is actually a wrapper around Bombardier, and both apps are now running, and you can see the state here. So I can see on the server that everything is running, and at some point, after a few seconds, it will stop. I can see some stats going on, and I'm not supposed to see that. Okay, it's supposed to run as a service on a machine, and it's stopping the jobs now. And if I go back on my client, my controller, I see the results. So I can see what happened. Job one, job two, which is the server and the application and the load. And here I see the results from the application and the results from the load. What's common between the two is that the CPU usage is provided. I have the memory, the build time, and the start time. Very important to measure how long it took to start the application first. And then the load itself return more important information like the time of the first request, how many requests were sent, how many bad responses, the mean latency, the max latency, request per second, and the max of the request per second. And this is typical from Bombardier. WRK doesn't return you the max request per second. It's like, I don't know how they do that. Maybe they sample it during 1 second and every second, and they return a mean request per second and a max request per second. But when we chart it, we always return the average request, the mean request per second, which is how many requests by how long. In this case, it was 144,000 by 15 seconds. Okay, that's the idea. So that's everything we get from this run. And you see, it was pretty simple. I just needed to run that. Now, if I was to change my local application, it will just send it again and re-benchmark it. Good?
Mm-hmm. Yep.
So from there, we can change the scenario to make it faster, because right now it was running 50 seconds of warm-up and 15 seconds of measurement. So I could do that either in the file by changing some variables, because Bombardier will use a warm-up and duration. So I could say warm-up, like 2 seconds, and duration.
And these names come from the job itself. So the job itself defined variables. So you have to look at the Bombardier definition to understand what variables are used in the command line arguments, and that would tell you what you can set in the section here to configure. So
here, and it's completely open, because the idea is that Bombardier, we have an arguments property that says, so if you know Bombardier, it's like AtipBench or WRK, they all have the same parameters. So the number of connections and the duration of the run. This is our own, you see, warm-up, duration, how many requests to send. If there is a rate defined past the rate. So we are templating the command line to run on the server. And this way, from our job, we can change all these variables. Like
you can override.
Yep.
We can override. So there is a default, and we can change whatever we want from wherever we want. And this wherever we want is either our own file here, or even on the command line. So if I don't want to do that for everyone, because the goal is to be able to share the scenario, but I just want to do it from the command line, I can just do --, and here a crank will look for an existing argument, and if it doesn't find it, it will bind it to the name of the job. So if I say load dot variables dot duration, it will just change the variable duration of the load job. But it will be easier for me to define a global variable to say warm-up equals 0. So there are many ways to define all these variables on the command line, on the job, as a global variable, or so that's the flexibility we have with that. And this
it's important because jobs are kind of defined as shared things in the benchmark repo, and devs can override without having to change files back and forth. Per run.
You can just change it in the command line.
Yep.
Send the job off. Question from the chat is, how would you handle, or do you handle cases where you have authentication required, like where you need to pass in a token or handle some sort of authentication scenario?
Yes. So we don't do anything here. It's up to your client and server to define how they will communicate. But for instance, if you use WRK, you can pass a script, because WRK supports Lua scripts. And there are examples in the WRK repository on how to intercept every request, to do a pre-flight request to get a token, and then assign this bearer token on every other request after that. So the idea would be to have your client support authentication. Another example.
Can you create a job, and then do we have output variables? I guess is the question I need to ask.
So you can repeat that?
Do we have support for output variables from jobs?
No.
Because I think if you did have that, I'll just do a feature design on the call. Hey, you could have a job that does a generic pre-flight request job that then emits a token into an output variable, and then you could flow that into the next job as a header, like a Bombardier supports sending headers, right, via a variable.
And what is interesting is that with this templating, we could just have a helper to, we could have something to bind the output of something.
Yeah, exactly. You could actually use a little DSL to do that. It would just do it for you.
So for instance here, what that's why I wanted to show. So if I do application.options.display output, because the application itself was outputting some version, okay? So here I can configure that to stream the output of my application to my local machine. So imagine you don't have access like I did here to the you can say, okay, show me what's outputting. And you see live, I see that my application started and I see what it's outputting. So if it's logging something, I can see it on my local machine. So we already have that. So yeah, in somehow we could be able to extract some values and then reuse it for the next job. That will not be hard actually. Good idea. So here, and now job is now building. This is for the next job. And if I Control C now, it will stop the client and every agent will just kill the applications that they run, but I won't do that. It should be quick now. Now it's done. But you see the idea. You can see the output of every endpoint of your system. Good. So that was the first demo. What I wanted to show now is how to run an actual thing on actual machines. So what I have here, I have 3 different machines, ASP per Flynn, Load, and DB. This is an environment we use to benchmark our applications before we look at them on the CI. So Camper is using an environment that they call Citrin, and we have the same one, same machines, but this one is a smaller one with 12 cores on each machine. And this is very useful for us to test regressions without having to add more churn on the machines we use for the CI.
I believe the correct name for those machines is the ASP.NET Smurf Lab.
Smurf Lab.
Fond memories.
And so to use 3D, so each of these have an agent running. Okay, so instead of running my own local app agent, I will use these ones now. And I will use another sample, which is the app you were complaining about, the nice app that does everything, the beautiful app. And I have a sample like this, so I call it trends here. And if I open this file, it's there. Now you understand how it works. It's importing the WRK job, the Bombardier job, so I have some choice here. We use WRK because it's doing pipelining, and that's very important for us because of Tech Emperor. And here in the job, I have the ASP.NET benchmark, which is not a local app, but something on GitHub. So we can also say, the app I want to benchmark is on GitHub, on this branch, and this is a project to build. Very interesting. And here, the variables for this app. So this app itself, when it starts, it needs to be defined. And Damien explained that, and it was kind of cringy because we are still using it. All these parameters, what scenario, what transport, what server, what protocol, all these things. And this is the command line to start this app. So this app can do many things, too many things. We break it eventually. It can do this, and we pass parameters to it. Then we also have the platform benchmarks, which is faster, but we won't care about it now. And the PostgreSQL job, which is a Docker file. And this Docker file is also on a repository. Okay? And we give it a name and the context directory and how we know that Postgres is ready by outputting that. And with that, we can define, let's say, the fortune scenario. So the fortune scenario on Tech Emperor is about having a database job that we use from the Docker image, a web application, and we'll use the ASP.NET one, and we'll configure it to say you need to run the DB Fortunes row scenario using the PostgreSQL database. This is the set of arguments that Damien was complaining about. We can also define environment variables because we want to pass a connection string. And then we'll define a load job using WRK with headers and hitting a specific path on a specific port. And now in the profiles, I still have my local profile, but I have more profiles. I have the one that is using the 3 machine I showed you. For the application, will go on the lean machine. For the load, will go on the load machine. And for the database, on the one that is called database. Okay, 3 different agents. And what's special with this machine is that they have a private network, private LAN. So from my network, they are known as these endpoints. But internally in their own network, with their own network card and own network switch, the web application is known as 10.0.0.102, and the database one as 10.0.0.103. So we are sure that the network traffic will be local without any interference from the public network. I just need to verify I'm on the VPN. I'm on the VPN. Otherwise, I won't be able to access this machine. And the profile is named ASP.NET Perf Lean. So now from the command line, it's very easy to point to this configuration, to select a scenario like fortunes, and the profile, the one that will send it to these machines. And I won't do that. Same thing, 3 command lines, 3 arguments on the command line. And if I start it, this will be the first one. Well, the first one to be deployed will be database. So if I look at my agent on database server, there is nothing. What is happening? PerfDB. Oh, I lost the connection. It's completely blocked. Okay, so I lost the connection on this one. It was blocked, but now the load has started. Also, David mentioned that. You see, it's pointing to what is currently running. So if I open this URL, this is what's the state of the job that is running on this machine. Okay, so I can follow, even retrospectively, I can see what happened on my on a run for each of the agents. So now it's done. So it deployed an app on each of these machines, ran, and then stopped when the last one was done. And the last one was the load generation. And what we get is the same result, but the difference is the web application that we're running is exporting custom information. So in this case, it outputted, not in the console, but as a metric to record the ASP.NET version and the runtime version. And in this case, it used a 5.0.1. This is the latest public version of ASP.NET 5 preview 5, and this is what it used. And this is the result we get in terms of requests per second, 107,000 requests per second on these machines.
Slow.
It's using the database, and it's these machines. Now, let's say I want to run it on netcore app 3.1. So what I will do is I will say the application dot framework will be netcore app 3.1. It will use the current version of netcore app 3.1, which is 3.15, and we'll get the results, and we can see if it's faster or not.
Not right. It should be not right.
Because we do a great job. Well, we do. The engineers, the ones who work on performance, I just measure the numbers. Because they do a great job, you will see that there is a nice improvement in terms of performance on the fortunes scenario. There should be.
It's always dangerous when you call it out early, Seb. You have to keep people. You have to string them along.
Yeah. Well, while it's doing this, I had a question about more distributed scenarios. And I know in this case, you've already got kind of distributed. You've got like a database, but I was even thinking about cases like Project Tie and things where you've got kind of more distributed things. I see a smile there. Is that something you've looked at, like more distributed scenarios?
Yeah, that's why we made also this system. So initially, before we rebooted this service, it could only support 3 nodes. A database, which was not actually enough for us. It was just a service that was running all the time. We could not deploy it, but it only supported a server and a client, and that's it. So why we made this system is to be able to deploy as many as you want on as many machines as you want. So I could deploy 10 of them on a single machine or 1 on 10 machines. And it's up to you to define all the jobs that you want to deploy. And
so
also,
for the real ones that we use, we have, for example, load generator web application database server, or we might have load generator web application backend API that the web application calls, or you might have 2 load generators web application and 2 Redis servers, for example. Like there's no reason we have got those type of scenarios that we run already, where we utilize multiple instances of jobs at various tiers. Which is more distributed than what you're seeing here, which is just effectively client server, right? So,
yeah. So Ryan Novak did some studying a few months ago, and he was deploying some web API, and then he was testing microservices. So he would deploy different apps on different machines to have actual microservice benchmarks to run. And something that even David is looking at is to be able to deploy n being a big number of machines.
Yeah.
To scales.
Yeah. So we've been doing some work to allocate less memory for WebSocket traffic. So what I've been trying to do on Twitter, trying to learn how to automate deploying Azure VMs using Terraform for no reason. But the idea is to install Crank agent on a bunch of ACI containers as clients. So I can spin up like 10 ACI agents for client load, and then have a big VM as my server application. And I could try to max out the number of concurrent connections per VM by picking a VM size, doing a test run, and then keep doing that over and over, upping the size of the VM to get more load into it.
Yeah, so it's not just about performance testing. We could also use this to do capacity testing or stress testing. Yeah, and they're all the same class. They're all basically part of the same family of test types, but they typically test for different outcomes, right? And so we used to have a tool in the IIS suite called the Web Capacity Analysis Tool, or WCAT.
WCAT.
And it was very similar to what you're seeing here, but built on XML and Windows and native code, C++ modules, and really only worked with IIS. And this is, in some ways a very modern version of that's vastly more flexible, and modern because it uses YAML instead of XML. But it can run anything, right? Like it really, really can run anything. So whether it's you're trying to say, hey, given a really big machine as a server, how many concurrent idle WebSocket connections can I connect? Like, can I connect 500,000 WebSocket connections or more? Well, think about the number of load generating servers you would need to open that many outgoing connections. One big load generating machine is probably not going to be either enough or available to you, right? Mm-hmm. But spinning up 100 container instances on your favorite cloud provider might be something that's available to you. And so that's exactly the type of things that Fowler's trying to look at right now, because when we're doing capacity testing or load testing, it's a somewhat different scenario to just performance testing, where you say, hey, connect 256 connections from one machine and then just pump them as fast as you can and measure the outcome, right? In this case, we want to get the server to the point just before it fails effectively and see how many connections it was at that point. And then we can take, a memory profile at that point and then learn what it is that's taking up the amount of memory for that many connections and make improvements. So the different scenarios, different styles of testing, but this orchestrator is generic enough that you can use it for both.
Right.
What I'm thinking here too is like, this is generic enough that obviously this makes sense for you for building a fast a web framework, but I could see people using this also for understanding overall performance impact of a distributed service that they're building, like a production.
Yep.
So absolutely, and that's what WCAT was originally built for, the old one. And there's no reason why, you couldn't stand this up against your actual application and then have jobs that represent your users or different, load types or user scenarios for your users, and then hit the server with a whole bunch of different, quote unquote live user code or user sessions and see how it performs, right? And I think the type of thing that Fowler's talking about is, imagine while the job is running, you could issue more, like interactively issue more load.
Right.
So you can actually observe what happens in real time. So the system looks stable now with 1,000 clients performing a split of user scenarios of task A, task B, task C. What happens if I add 2,000 new clients who come in and try to do task D because like they hit a marketing banner on some website or something, right? That type of interactive load testing is the type of stuff that is often done in the real world for capacity testing of sites. But you need that bursty kind of ability to orchestrate a whole bunch of folks turning up at one point. And so I think that's what Fowler's been looking at this last week with trying to automate things like ACI.
So we don't just have to have Hanselman tweet it. We can actually run
Yes, exactly. Twiddle load tests.
Wow.
Yeah, so it's also given, so before, back in the olden days, Seb used to write the infrastructure and every benchmark. And this decoupling has let Seb focus on the actual infrastructure itself, and individual teams own their benchmarks. Blazor, Signalar, ASP.NET Core.
James made clients for that, custom clients.
Right, exactly.
Yeah, because it doesn't focus on, that's a really good point. This is the infrastructure layer. It's not the layer that says, what type of requests are you going to make and what behavior do you want? Like Seb said, he's got a couple built in. He's got Bombardier and he's got Work.
Right.
But if you wanted to do more of a user, VS has tools for doing, like, you record a user web session and then you play it back at scale, right, against a server. Those types of user testing or acceptance or stress testing scenarios, this doesn't care about, it doesn't know about those things. It's just a job. You would write a job and you either put that stuff in a container or an exe or in just a .NET project, and then you configure a job to run that, right? And so anyone taking Crank could then integrate in any other thing that generates the type of traffic or does the type of behavior that they want to, including, as Seb showed before, capturing custom metrics, right? You can capture custom details from whatever your custom client is, and then that will be collected for you by Crank because it has those generic capabilities.
I wanted to find, yes, here. You see here, this is a gRPC file made by James, and he made custom client apps to generate gRPC traffic to benchmark the gRPC scenario. And it's just a console app he made in .NET and then a YAML file. And then from anywhere, we can simulate that. And now I think this is the AAD team is using this client to test their gRPC traffic on AAD. Or they copied some code to make their own client to test gRPC traffic for performance reasons. So that's it.
And you could imagine an ecosystem of jobs defined somewhere on GitHub that you could pull in as like for your own jobs, right? So if somebody made a gRPC client or Work client Bombardier, you can reference their thing from GitHub directly in your script, but don't having to build your own clients for everything. So
or if you were building a WebRTC video application, as long as you can write an app that can create a client or emulate client traffic on that, you could orchestrate like the load testing that environment using something like Crank. So it really is that layer underneath, and you get the flexibility to write the jobs in whatever language you want that actually execute the various things. So
So while you were talking, I ran two jobs. I ran the JSON scenario within the same file that was defined here, and I stored them. So to store a job, I use the output parameter, and I saved the first one JSON 3.1, and the second one for 5.0, I saved it under JSON 50.json. Okay, so it creates a file like this. So if I open it, JSON-50, it shows me here for each job everything that it computed, and you see here also the ASP.NET conversion, which was returned, the metadata, which describes every measure it took with description and what it is, all the measurements, like all the samples it took from every metric, build time, CPU, swap, everything. And it does that for all the nodes of your deployment, specific to the Burger Arcade, from the host, first request, things like this. Okay, so that's stored. And this is also what will be stored in SQL if you decide to not use the -- output, but the -- SQL option, which lets you store the results in SQL database that we use for Power BI, for instance, or you can use for any charting. It will store the result in a JSON document in your database. And from that, we can also decide to compare the results. So there is a command in Crank, which is called compare, and I can say JSON 3.1 and JSON 5.0. And it will just show me a table with all the things.
Well, that's hot.
Yeah,
That
that's
is
pretty
awesome.
Oh, compare.
It's like benchmark.net, but by pivoted 90 degrees. So because we have lots of metrics and it doesn't fit in the screen horizontally, so it has to be vertical. And this way, so this is a command to compare already existing measurements. But what you do usually is that you do a baseline. So you run a benchmark and you output it as something, let's call it baseline, without your changes. Okay, that's what our engineers do. So you do a baseline and you output it with your, like, for instance, 3.1 or 5.0. And then once you have that, you change your app or you change Kestrel and you build a DLL. And let's say you change Kestrel. Let's say you are Ben Adams and you change Kestrel every day. You do -- application dot output files, and then you pass kestrel.dll, like your local file, like c:\code kestrel.dll, and it will upload this file on the agent to be benchmarked inside the app that it deployed. So this is super useful for our engineers because they can test their local changes on actual benchmarking servers that are stable, not their local machines.
Mm-hmm.
And from there, they can say compare baseline.json, and instead of saving the result, which you could still do, but it will just output this table from the baseline as the column here and the current results in the column there. So they can just do change, build, run benchmark, change, build, run benchmark, and they will see the result of their local changes on the actual application that they are measuring, which can be ASP.NET applications or your own user application to see the impact of that. So that's the flow that engineers use to track the improvement of their local changes. And by the way, if you look at the request per second on JSON, which is middleware version, so the standard version, between 3.1 and 5.0, and 5.0 preview 5, not even preview 6 or 7, okay, which is actually faster, you get plus 22% on these machines.
Wow.
In request per second. And all the latencies went down. Even the build time went down. See, so
Question. Did you show the collect counters feature?
I have so many things to show. So here. So
it's been years.
Yeah, I'm sorry. So here, the idea is that I'm running it on Linux, but if I want to switch on Windows, I can just say Win here, use a different profile, okay? Because I have defined a profile that is using a Windows machine. And I could compare Windows to Linux if I wanted. And I use the latest here, Netcore 5.0. Actually, not the latest, but Netcore 5.0. And you can say collect. So let me do that. Application dot. Sorry, I don't have it. I need to look at the.
You don't have it all memorized?
I know, but there is an argument I don't know by heart.
Collect counters. What do you mean?
Sorry, the collect counter. Sorry, don't.
Options.
Wait, no, I will do something else first because I'm at that. So controller readme. Here, I want to do collect true. And I want to do that thing.
Yeah, I'm just disappointed you didn't have that all memorized.
Yeah, Seb.
So I will do that. So what I'm saying is that I want the application, well, the agent that is running the application to collect a trace. And this is the collect arguments I want to send to the application that is collecting a trace. This argument is from purview because I'm targeting a Windows machine. So these collect arguments will be for purview. And if I was targeting a Linux machine, I could pass the perf collect arguments, perf collect arguments. So this is the native traces that we get with collect true, and you will see what's happening. Then we have another option, which is .NET trace. So I can say .options.NET trace, and then it will use the new .NET trace tool to take the trace. And we'll have the managed trace. And what happened is that the server took the trace using purview, and the driver is now downloading the trace. And that's why I have an ETL file here. Okay. Who knows how to start purview and to collect and to stop when it? No, here it just say I want the trace. So what I just need to do now is I can just copy the path here. Start purview. The folder and open that. And you should see the JSON serializer and the thread pool. So if I select now, what is the app? Benchmarks, which is the app I just ran. And we can see Kestrel is slow. And there is a middleware. And this is a JSON middleware, okay, which is invoked. So we can then go there and see what's happening inside. So you can see, this is you just got a trace that you can then analyze but that's how you do. And that's how you pass custom arguments. And what David was asking.
What's the one? Is that similar on Linux to dtrace, or is there something? I get it now. This is different. Yeah.
So yeah, on Linux you would use perf collect, perf and perf collect.
Perf, yeah. There's perf. There's what's it called? There's dtrace. That's more of a free BSD thing, but I think it got ported to Linux. And there's one more called. What's the name of it? I can't remember the name of it. There's one called, I think, bperf. No, something else.
So what David wanted me to show you is that thing. So what we do also is that we can collect .NET counters, which is a thing that was added into 2.
And yeah, 3 for real. It was kind of broken into 2.
Do you have to pass collect counters true and the providers?
Yeah, but I want to show you so if you just do that, it will grab all the system runtime counters, the default system.runtime counters. And this is what we saw in the charts with the GC allocations, GC heaps, thread pool, stats, looking contentions. And so counters is super useful. It's like the framework and the different libraries can provide whatever numbers they want to expose to the app or to the agent to track them. And every subsystem can define their own. And this is actually how we expose also our metrics in the agents. So here you see I have much more information. So on the application itself, I now have all these counters that provided some data. It also provides a CPU usage, which matches almost what we tracked. Memory usage, you see GC heap, GC information about allocations, heap size, exceptions per second. All these things are super interesting. And because each system can provide their own counters, here, if I pass that, we just use the Kestrel one are too new. I need a new version. But which one is the newest? I think, yeah, Kestrel is the newest. So if I do that, it will actually use, what did I do?
Counter providers or provider?
You see, that's very interesting because it says that I don't know this property. So here.
That was a guess, by the way. So profiles, counters, a lot of features.
Traces, save results, specific versions.
Seb has been in his cave basically working on this thing for about, I don't know, how long now? Maybe 6 months? The new version?
Yeah, we started around September, I think.
Yeah.
More than that.
Are we going to put these poor folks out of their misery? Everyone on the chat just wants to know.
They're going crazy.
They're going crazy. Come on.
So you see here, we get the ASP.NET Core counter, so requests per second, which should match approximately what Bombardier sees. Okay. Number of requests. So what's interesting is that ASP.NET counted 1.6 million requests, and the benchmark said, I just sent 1.1 million requests. So there is a mismatch.
Some bug somewhere.
Yeah, that's interesting because when I did that with specific number of requests on Bombardier, I think this is a WRK. But if I use Bombardier, it matches exactly the number of requests. So that's interesting.
So work is buggy, is what you're saying, because
maybe the tech
we don't have bugs.
I don't know. Something also interesting is that you see here, I'm using just the preview file, which is the latest public version. Let's say I want to use the latest nightly build of ASP.NET Core and runtime. I can just say application, and I don't change the framework, but I can change the channel. And here I can say edge and get the result using the latest available bits on the feeds, which might have been just built an hour ago, maybe. So this is how we change the version. And you can do the same thing on each framework. So super useful. And not only can you define the channel to just get the latest version or the current public version, but you can also set a specific version. This is very important when you benchmark, because let's say you do a change on Kestrel. You don't want the runtime to change every time you run a benchmark. You want to use a stable runtime version, meaning one that doesn't move. So you will run a benchmark and copy paste the version of the runtime. And then instead of using edge for the runtime, you will use this version. And you can then change the ASP.NET target that you want to measure on. Okay. The goal is that when you do 2 runs, you might not run 2 different versions of the runtime because there was a new build available. And now you just measuring you don't know what.
Right. So you want to lock in the version.
Exactly, lock in. Thank you. And you see here, now it's using preview 7. On a build from the 16, which is today the 5th build on the 16. So today, this is the 5th build that we're using from the runtime, and same thing from ASP.NET. Okay, so that's super useful to track the performance of ASP.NET, maybe also on your own apps. Maybe you want to see what's the impact of the current ASP.NET version on my app. I don't know. For us, it's super useful because that's how we do the things. We want to track the latest version of everything, but it depends.
We had a question about benchmark.net, and I know we did something special there, but it may not be in the new version yet.
So the old version, the old driver support, well, the server supports that. The agent supports it, but the driver, the new one doesn't know how to download the results right now. The old driver knows to do that, so I haven't ported that. But to show you, because this graph here is using the old driver still. And the EF core benchmarks, they are micro benchmarks. They are benchmark.net benchmarks. And each result here is a class. So yes, it's supported. We can run using exactly all the same comments by changing the frameworks, by doing .NET counters, but doesn't make any sense in this case. But yes, you can run benchmarks continuously using benchmark.net. And this is the kind of results that you can get. You get the same results. It's just that the way they wanted to show it was to show a chart per class. You could also have a tree view with all the classes and all the methods and just check them as you want. But yes, it's supported. Not in the new, so Crank itself doesn't support it, but Crank agent supports it. So it's just we have to port every feature to the new controller. Something I didn't mention that's super useful for microservices is that you can say application and then restrict the CPU set and memory on the server. So let's say I just want to run with 1 core. I can say CPU set 0 to take the core number 0, or 0-2 to say cores 0, 1, and 2. And if I run that,
do we have docs for this, Ed?
Yes.
Perfect.
CPU, it's not here.
Guess not.
So the answer was actually no.
How is it possible?
Well, we're about at time. And I realize you have 1,000 different things to show off here. This is cool. But so some kind of wrap up questions. There was one. So I had mentioned like the microservice and Thai as an option. There's a specific question. Can you use this directly with Thai, or is it more like, well, Thai, you could configure your environment with Thai and then you'd wire this up?
Neither. They're both today very similar in how they launch and manage a process, but there's no overlap today.
Okay, cool.
Yeah.
I guess the one other main thing people are just asking, like, when and how can they start using this as well?
Soon, hopefully, if we get lucky this week. My boss has to like hit approve, and then it'll be boop. It should be easy.
Cool. And you mentioned too that you're that there's a Docker container available too, right? Or there will be. Is that true?
So there will be. There is a Docker file that you can use. That's how we deploy the thing here.
Ah, cool.
We use the Docker file, but yeah, we want to build a Docker image. So you just have to reference this image or run this image. You don't have to build anything, but there is a Docker file at least.
Okay. Anything else in closing? Which people you showed the expected repo, I guess, and then we. How else will people find out about when this goes out? I guess over.
We will tweet it out of the wazoo.
All right.
People will know. Stay tuned.
Blog post too. So Seb will do a blog post.
Cool.
There you go.
All right. Anything else in closing?
No, we're way over time.
Yeah. Okay. This is super wonderful. This is really cool. So I think, I love the side of it that I know that my applications keep getting faster magically because I write them because I picked a winning web framework. So that's cool. But then it also is neat to think about like opportunity to benchmark my applications too, so that is very good stuff. Good job, Seb.
Thank you.
Cool. All right. Let me see. Can you unshare your screen and we can all wave goodbye? Yay! Oh shoot! And this is again the thing where I don't have. So Damien figured out how we can do dramatic zoom out, and I have not configured it yet.
We will
it's
get
on the
there.
Backlog.
Maybe we'll get it for the upcoming Hanselman and Damien show. We'll see.
There you go.
Yeah.
Awesome.
Scroll down.
What's that?
Scroll down.
Yeah,
it
right.
will unzoom. It works in Teams. If I share my screen, I control zoom out.
Oh, wonderful. All right. Thanks, everybody. Goodbye.
Yeah.